Today I'm standing at Gale Common, which has somewhere in the region of 25 million tonnes of reserves of coal-derived fly ash. The UK QAA has been working with the Concrete Technology Unit at the University of Dundee to see how this legacy stockpile of fly ash can be processed to meet European standards for use in cement and concrete. Coal-derived fly ash, CDFA, has been used for many decades as a secondary cementitious material in the UK. Not to mention sustainability credentials such as reduction in the use of virgin materials and avoiding much of the CO2 associated with cement production. The physical and chemical properties of CDFA offer a unique combination of properties in concrete such as flow, cohesiveness, durability and low heat for mass pours. Now that the production of fresh CDFA is becoming scarce as a result of the closure of coal-fired power generation, which is taking place in both the UK and Europe, the emphasis is on what can be done with the legacy stockpiles. These are estimated to be more than 100 million tonnes in the UK alone. But there are challenges with stockpiled ash: high moisture, particle size and carbon content. A Tritter, with over 90 years of experience in drying and milling, and ST Equipment Technologies, who have been removing carbon from fly ash since 1995, have the technical solution to overcome such challenges. This resulted in the idea to combine the Tritter and STEP pilot plants so that industry leaders would be able to witness for themselves stockpiled ash samples being processed. After all, seeing is believing. The STET containerised electrostatic separator was shipped over from the USA to sit alongside the Tritter drying and deagglomeration pilot plant in Coventry, a world first.
Welcome to the Tritter and STET Ash demonstration event.
50 of the key stakeholders ranging from power utilities, cement producers, distributors, trade bodies, government and the media came along to witness a live demonstration. Harvested CDFA was delivered from sites across the UK for the event. The ash is fed into an agitated feed vessel in the Tritter pilot plant. An inclined screw drops it into a hot air stream and then feeds it into the Tritter dryer pulverizer. It is here that the ash is flash dried and deagglomerated to meet international standards in terms of fineness. The deagglomerated and dried material is then collected in the bag filters to feed into the STET electrostatic carbon separation process. In only a few seconds, the STET separator utilises the differential electrical charge properties between the mineral and carbon content of the dried ash to produce two value streams: an EN450 quality fly ash and a high carbon material. The STET separator employs a fast-moving proprietary belt to electrostatically charge both carbon and mineral particles fed into it. Once the process is complete, visitors are invited to the Tritter lab to witness testing for conformity to international standards in Europe and the USA. Whilst there can be variability, both within and between legacy stockpiles of fly ashes, the combination of the Tritter and STET technology results in consistent processed ash that makes an excellent secondary cementitious material. A material that enhances the properties of cement and concrete with strong sustainability credentials, and a material that fits into the goals of a circular economy. The high carbon material offers potential use in several different applications, ensuring that there are no waste streams to deal with.
I think the ash store technology is really, interesting. the way they're deagglomerating rather than grinding to make sure that the ash maintains the particles and the things that make it cementitious, which is really important for use in cement and concrete. And then the step technology just to separate out that carbon. I think you need both together to produce that useful product at the end. They're both just really interesting. The two companies working together is great to see.
I am absolutely delighted with this visionary pilot plant project between Attrita and Stet to demonstrate to a wide range of stakeholders how fly ash can be processed to meet their various needs. In fact, I've never been more confident in the long-term future of this highly versatile building material, and I very much look forward to seeing the first commercial plant in operation.